All right. Hopefully you can see that all right. Thank you for the very warm welcome, Florian, Alessio, and Tony. It's a privilege to be able to speak with you all at the GeoNodeSummit this year as one of our first presenters. My name is Matthew Northcott, and I will, of course, be taking you through my first steps into free and open source software, which concerns my involvement in the upgrade to GeoNode 3 at Catalyst IT New Zealand. During my presentation, I aim to take you through my personal experiences as a junior developer and share an insight into what might make open source technologies more accessible for contributors in the future. So a bit about me. I was employed by Catalyst as an intern at our company's GIS team. We're a small but growing team of dedicated developers who use GeoNode for our clients' needs, which is mainly to serve as a geospatial data portal for 2 district councils in New Zealand. Now, I must confess, I did not actually possess any background GIS experience before jumping in. I've really only involved myself as a user of open source technologies by having developer experience on a Linux platform. However, I've, um, I've not been involved in any contributions to an upstream project before, and GeoNode was very much a first-time experience in this regard. Nevertheless, I was keen to change things and get started, as I do have experience as a developer. I hold a Bachelor of Engineering with honours in computer engineering, but this qualification is not at all software focused, really. It's more oriented towards electrical first principles of computer systems and embedded systems programming. So how did I get started? On paper, I have no business here with my lack of GIS knowledge and my mostly electrical degree. A project like GeoNode is massively intimidating coming from this angle. Well, the task sounds far simpler when broken down. Upgrade Python from version 2 to 3. Challenging, yes, especially with a big piece of software like GeoNode, but entirely possible. Then upgrade Django from version 1.11 to 2.2. Sounds fine so long as we identify the breaking changes and plan accordingly. The upgrade to each of these marks the upgrade from GeoNode 2 to GeoNode 3. Of course, something like this is easier said than done. Luckily, with a strong team guiding me, we developed a plan of attack. External dependencies are often available in Python 2 and 3 cross-compatible versions, so this became our starting point, upgrading each of GeoNode's dependencies to new versions that would allow a direct transition using the same version once GeoNode itself reached Python 3 compliancy. Therefore, we could run GeoNode 2.10 with the new packages installed to verify compatibility after each dependency was updated. Python 3 compliancy, of course, became our second step. This involved upgrading each of our GeoNode's core Django apps to find within the main repository. Again, special care had to be taken here to maintain Python 2 compatibility so that we could test each major change one by one. All of this made the eventual upgrade to Python 3 less of a leap and more of a jump. Finally, as you might expect, that jump I referenced introduced a variety of new problems. This is where the usefulness of the test suite and the Travis CI runner really began to shine. We identified and squashed many of the bugs at this stage. Most were easily fixed oversights, but some grew into far more complex issues that ended up spanning farther back and requiring more elaborate solutions than we previously anticipated. And I'll get into that later. To send it all home, GeoNode 3.0 was released on the 18th of May 2020. This was a really monumentous occasion for me, as it was payoff for basically 10 weeks of hard work on the platform I didn't even know about had you asked me 6 months earlier. Between November 2019 and February 2020, I had approximately 3,700 code changes merged into GeoNode's main branch, spread out across 28 pull requests. Given my history, or lack thereof, I consider this an incredible result and an absolute win for my first contribution milestone. I am remarkably thankful for the guidance of my team and for the help of our maintainers, just getting this far. But that journey is far from over. So based off the back of the success of GeoNode 3, I was given the opportunity of a more permanent role at Catalyst. So from here on out, GeoNode was no longer my main project, but that didn't stop our ongoing support for the product. So my next contribution involved the replacement of of the local file system operations that use Python's built-in OS library to use instead Django's file storage API. So this allows the use of Django storage Swift to be installed and used correctly. You might ask what our motivation was. It was to provide OpenStack Swift object storage support to our GeoNode. As one of Catalyst's main products is an OpenStack-based cloud service called Catalyst Cloud. We can then use this extension to store static files and user uploads of our clients in Swift containers hosted on our own cloud service. For those of you now using GeoNode 3.1, support is included. Of course, we couldn't possibly get every feature and every fix into the GeoNode 3.0 release. Some things had to wait, and with that, I introduced a final problem. Search by extent. If you're not familiar, GeoNode allows you to query layers based on a view area of a map. So on the left panel there, you'll see we're querying layers by a bounding box or by an extent encompassing Australia, New Zealand, some of Indonesia there, and a little bit of Southeast Asia. Now the feature works by defining a box of 4 coordinate pairs based on the location of the user's map view and finding other bounding boxes that intersect with the one we define. The example there would query the whole world map, so the limits of the search should be within plus or minus 180 degrees, plus or minus 90 degrees, using the world geodetic system. So what's the problem? Well, with the way this is implemented in the current version of GeoNode, it's not quite ideal. There's a lot of manual work being done, and it proves to be inefficient and sometimes problematic. I say this because testing during the development of GeoNode 3 outlined search by extent as a problem to begin with. And so what was the solution? Well, as a team, we decided that PostGIS was the solution. PostGIS is a database extension for Postgres that provides all the functions necessary to perform this query efficiently from within the database. No real processing is done by Django. However, this required 2 things to happen. Firstly, it will require a transition to integrate PostGIS in the database used by Django. This is not to be confused with the existing geospatial database GeoNode uses, but rather the same database storing, for example, user data. Secondly, this required a complete transition from the old bounding box definitions in each of our layers to polygon fields understood by PostGIS. Excuse me. You can probably imagine there was a lot of work to do, and you'd be right because it was quite an undertaking both in time and complexity. Intermittent work between May and October saw a further 1,000 code changes being accepted into the main repository. But we expect those to be available in the next upcoming release of GeoNode. And my appreciation has to go out to Alessio for reviewing that patch. So thank you. So what are my experiences from all this? I'm upgrading GeoNode to version 3 and the subsequent work on search by extent. I had to sit down to think about this, and I've been able to summarize 4 main aspects of the open source software that are crucial to a smooth onboarding of a new contributor. Boils down to this: documentation, procedures, code quality, and application. What do I mean specifically? Well, I'll go through that shortly individually, but know this: it can be far more difficult and therefore take a lot more time to get started if a project is lacking in any of these areas. Application, though, is an exception because you can't typically control this. You can't take the GIS out of GeoNode, for example. Documentation. No one likes writing documentation, but it is an essential part of any project. As such, there should only be one location to find said documentation, and this must be well advertised. For example, provide a link in the repository's README. I actually checked GeoNode's README this morning, and there is actually no direct link to the homepage of the documentation, which was a surprise. Um, considering the README could very well be the first point of contact for a new contributor, it's not really ideal. It can definitely be frustrating when when you don't know what to reference between the GitHub wiki, the docs, multiple mirrors that seem to exist when you do a quick Google search. The documentation should be well categorized or even split between user and developer documentation, like, for example, GeoServer. Categorization is a simple principle, but it's often difficult to get right. GeoNode's documentation is pretty good with this, but again, it's more the structure of these categories that counts. The how to contribute section should be at the beginning, or at least be a subsection within the getting started section. Installation and configuration instructions for users are more important, but that doesn't mean developers should have to hunt for information relevant to them. I acknowledge that contribution details are largely documented on the GitHub wiki pages and linked via the README, but we could absolutely reduce the learning curve by introducing something like an FAQ section that makes the contributors agreement easier to understand for someone who has never encountered one of these before. Lastly, going back to the README, I noticed that there's no explanation as to how the project is built up or how the repository is structured. Maybe I noticed there's a bug where a value in one of my layers attribute tables doesn't display correctly. I have developer experience. Where do I go looking for the specific feature I want to fix? After all, GeoNode is a large piece of software comprised of over 96,000 lines of Python alone. I want to mention the other components. This is a seriously intimidating figure to a junior. We've actually hired new interns to work on the Catalyst GIS stack over the summer, much like I did a year ago, and we've really had to acknowledge this perspective and shape up our internal documentation this time around. But honestly, the differences made has been substantial for our onboarding process. They were able to pick up the context far easier and get to tackling the real problems much earlier on. It's been really amazing to see. Code quality. Code quality really comes down to good programming practices. It's no secret that there are some very old functions and files in GeoNode that have not been changed since the project's inception, and I understand why. They work. They function exactly as they did when they were written, and normally this isn't a problem, but it's certainly a problem when the code is written with the intent of fixing it later. We've all been there. Break this down further, document this. It's easy to leave it be if it works. It's hard to improve and even harder to justify when functionally you'll see no difference once you're finished, except it becomes easy to justify once you consider the next person looking at your code. Me, for example. I come along, I clone GeoNode, and I am faced with this a 456 line function. So what am I to make of that? Well, there are a few comments within the function body. There's no docstring, what it expects as input, and what it returns. Hence, my first two tips concerning code quality are, firstly, comment complex sections, functions, and classes. Secondly, only accomplish one task per function. Subsequently, each unit should work on its own and possess the ability to be tested in isolation. When I say unit, I mean individual functions, classes, modules, Django apps, and repositories, with each abstracting the last. This makes the project more modular and thus more understandable. I think GeoNode handles the higher level abstractions quite well, but as we've seen, there is room for improvement as these abstractions become more granular. At the highest level, though, this concerns the many repositories within the GeoNode project. It was actually great being introduced to the structure, as I knew that much of the project outside of the core repository had been stripped away, relieving some of those initial overwhelming feelings. Hence why I conclude with this as my final point pertaining to code quality. Procedures. When it comes to being first introduced to a project, like any other user, a developer has to first know how the software works and what it does. Understanding this is a prerequisite to understanding how the software works from a more technical point of view. Therefore, a demo should be available in one command from first cloning the repository. Alternatively, a demo site reduces those steps even further, so hats off to GeoNode in that regard. In fact, GeoNode is a great example of how an open source project should handle procedures and processes. To iterate the points on my slide there, there's a demo site to provide an example of the product. There's Gitter as a primary communication platform documented on the README. There are well-defined pull requests and issue templates on GitHub. And finally, the code review process is explained within the pull request template, exactly at the stage where you might want to know that information. So being presented with this upon creating my first pull request was actually really relieving. Simply defining all of your PR steps labeled as checkboxes is possibly the most intuitive solution around this problem. It's methodical, informative, and instantly made subsequent mergers less intimidating. It's just getting to the stage, which is the most difficult part of the contribution process, but we've addressed how to make this obstacle more surmountable in sections prior. From here, though, it's more or less plain sailing. That about summarizes my thoughts surrounding making open source projects more accessible in the future. Overall, GeoNode has been great, both as a starting point and as an ongoing project in my open source journey. There have been many challenges along the way, certainly, but as a learning experience, especially, it's been excellent. If I can turn back time, though, I would like to have actually implemented some of these changes into GeoNode as I encountered them. Because I found new things challenging. There were probably many instances where I could have improved a piece of documentation to clarify something I found obscure, a comment I could have added to aid in understanding. So if you are starting out, not even as a developer per se, but just on a new project, do consider what I've shared with you today. It only takes a minute to potentially save hours of someone else's time. So to conclude, I hope this reflection and proposal carries with it some inspiration on how GeoNode or any other platform you might be involved with could be improved in the future. Open source software is ever evolving by nature, and it's our responsibility to maintain and improve it for those yet to begin their journey. So to everyone who has helped GeoNode get to this stage for juniors like me, I thank you. A special thanks to Alessio Fabiani and Tobias Schulman for their guidance and help. And finally, to all who are attending this GeoNodeSummit or watch this in the future, thank you for listening. It's been a pleasure speaking with you all, and please enjoy the rest of the summit.